Today we will discuss some problems based on the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. So viewers, this is a very important property for evaluating the definite integrals. So let us take the first problem. Here we have to evaluate this definite integral from 0 to pi by 2 log of 10x, right? Suppose let us call this integral I. Now here the value of a is pi by 2, and let us apply this property to this problem. So I is 0 to pi by 2 log of 10x dx, right? And let us say this is equation 1. Now applying this property to this integral, we have I is equal to 0 to pi by 2, we have log tan of pi by 2 minus x. So here we have replaced x by a minus x, and a is pi by 2. So this is dx, and I becomes 0 to pi by 2 log of cot x, because tan pi by 2 minus x is cot x. Now see, here we have log 10x. Now we have reduced this function to log cot x, right, by virtue of this property. So now what we will do, we will add equation 1 and 2. So we have I plus I, here we have I plus I, and then we have 0 to pi by 2 log 10x dx plus 0 to pi by 2, then we have log cot x, right? Now this is I plus I is 2i. Now we have 0 to pi by 2, and then we have log tan x plus log cot x and dx, right? Okay, because here the limits are same, therefore we have written log tan x plus log cot x. Now we know that the property of log m plus log n is equal to log of m into n. So log tan x plus log cot x is equal to log of tan x in multiplied cot x, right? And log tan x, and here for cot x we can write 1 upon tan x. So tan x and tan x get cancelled, so we have log of 1, that is 0. So therefore here this term becomes 0, so we have 0 to pi by 2, here we have 0 dx, so this is 0. So therefore 2i is 0, that is I is 0, right? So the value of this integral is 0. Viewers, let us take this problem. Here we have to integrate this integral from 0 to 1 log 1 over x minus 1. So let us take it as equation 1, and we will apply this property to evaluate this integral. So I is now 0 to 1, we have log, here the value of a is 1. So now we have log, first of all let us write this integral in a simplified form, and we can write it as 1 minus x divided by x, right? So let us now call this as equation 1, right? Now applying this property to now this integral, so we have I 0 to 1, and we have log 1 minus, now here this x is replaced by a minus x, that is a is 1, So we have here 1 minus x, and here also x is replaced by 1 minus x, right? Okay. Now if we simplify this, we get 0 to 1. We have log 1 minus 1 plus x divided by 1 minus x, and here we have dx also. Here also we have dx, and now I can be written as 0 to 1 log 1 and 1 get cancelled, so we have x divided by 1 minus x, right? So this is equation number 2. Now we will add both these equations, 1 plus 2, so we have I plus I, and here we have 0 to 1 log 1 minus x over x dx plus 0 to 1 log x divided by 1 minus x dx, right? So I plus I is 2i, 0 to 1 log. Now since the limits of integration are same, so we can write it log 1 minus x by x plus log x over 1 minus x, and here we have dx, right? Now again we'll apply the same rule, that is log m plus log n is equal to log m multiplied n. So log 1 minus x by x, this is m, this is n, so we have log 1 minus x over x multiplied x over 1 minus x, right? So 1 minus x get cancelled, x and x get cancelled, so we have log of 1, that is 0, right? So this becomes 0 to 1 log of 0, it becomes 0 dx. This expression becomes 0 due to this property. So this is equal to 0. So 2i is 0, hence I is equal to 0. So therefore the value of this integral is 0. Now let us take this problem. Here we have to integrate this definite integral, and this is from 0 to pi by 2 sine 2x log 10x. So let us call this integral I, and we have I is equal to 0 to pi by 2, and say this is equation 1, and let us apply this property to this integral. So here the value of a is pi by 2, and this is sine 2 times here the x is replaced by pi by 2 minus x. So this is sine 2 times pi by 2 minus x. Then we have log tan pi by 2 minus x, right? Okay, so I becomes 0 to pi by 2. We have sine, this is pi minus 2x, and this is the log of tan pi by 2 minus x is cot x, right? And now I can be written as 0 to pi by 2, and sine pi minus 2x is sine 2x, and here we have log cot x, right? Because sine pi minus theta is equal to sine theta, right? Okay, now this is equation 1, and let us take this is as equation 2. Now if we add 1 and 2, we get I plus I, and then we have 0 to pi by 2. Here we have sine 2x log tan x and dx plus 0 to pi by 2 sine 2x log cot x dx, right? Now since the limits of integration are same, so we can write 0 to pi by 2. This is sine 2x log 10x plus sine 2x log cot x. Clear? Okay, here we have dx. So 2I becomes 0 to pi by 2. Now taking sine 2x as common, we have log 10x plus log cot x, right? Now log 10x plus log cot x, so again applying the same property of log, that is log m plus log n can be written as log m multiplied n. So log 10x plus log cot x, log 10x plus log cot x can be written as log of 10x multiplied cot x, and here we can write this is log 10x times 1 over 10x, 10x, 10x get cancelled, so we have log of 1, that is 0. So this term becomes 0, so therefore 2I becomes equal to 0 to pi by 2, and here we have sine 2x, and this expression becomes 0, so here we have 0 and dx. So 2I is 0 and I is 0. So therefore the value of this integral is 0, right?